In this video, we're going to talk about how to find a reference angle. So let's take a look at the definition we have here. The reference angle, well, suppose you're given a theta in a standard position, meaning you can draw it from the positive x-axis. Its reference angle is the positive acute angle, so that's the key idea. Positive acute angle formed by the terminal side of theta and the x-axis. So super important definition. So you have to keep these three things in mind when you're drawing a reference angle. So there is a specific rule if your angle terminates on the first quadrant, second quadrant, third, and fourth. So suppose you have an angle that terminates on the first quadrant, right here, which means the angle itself is already between 0 to 90, and it is forming from the positive x-axis and to the terminal side. So the theta is its reference angle. So there is no really a rule for first quadrant because it's just the angle itself is the reference angle. Now what about the second quadrant? Suppose you have an angle that terminates on the second quadrant, so just like that. So this is theta. So where is the reference angle? Well, by looking at the definition, the reference angle is this angle right here. It is formed by the x-axis and the terminal side of theta. So this piece represents our reference angle. So how do we find this reference angle? So the rule that you would follow to find this reference angle would be to do 180 minus theta, or if it's in radians, you would do pi minus theta. So that would be the rule to follow, because theta means you have completed half of the circle, which is all of this, and you just want to remove theta. So if you remove all of that piece, you'll be left with the orange piece, which will represent the reference angle. Now let's look at the third quadrant. So if we have an angle that terminates on the third quadrant, and we want to write down the rule to find its reference angle. So suppose that is our theta, and we want to find the reference angle. So again, strictly following the definition, the reference angle is formed by the x-axis and the terminal side. So this piece is our reference angle. And how do we find this piece? Well, we would have to do theta, because that's the entire angle, and we're going to remove 180 from it. That will give us that remaining piece, as you can see it on the graph. Or if it's in radians, you would do theta minus pi. And lastly, on the fourth quadrant, if the angle terminates on the fourth quadrant, how do we find its reference angle? So this is the theta on the fourth quadrant. So let's draw out the reference angle. Here is the x-axis, and here's the terminal side of theta. That piece represents our reference angle. So in order for us to find this angle, we're going to do 360 minus theta, because that would give us that remaining piece. Or in radians, we would do 2 pi minus theta. So these are the 4 different rules we have when we want to compute the reference angle for any given angle. And now let's take a look at some examples. So suppose we want to find the reference angle for, so let's go ahead and find the reference angle for the following. Let's do theta equals 345 degrees. So first, what you want to do is sketch where theta belongs. So here's our coordinates plane. So we know this is 0 degree, this is 90, 180, 270, and 360. So 360 is exactly the same as 0. So 345 is between 270 and 360. So we can say that the angle terminates right here. So that would be 345 degree, which means we're going to be using rule number 4 to find the reference angle. So the reference angle is this piece right here. That is our reference angle. So to find this angle, we're going to take the degree measure, 345, no, sorry. We're going to take 360 degree measure, and we take away 345. So that would give us the angle in degree, which is 15 degree. So that is our reference angle for 345. Now let's take a look at another example. Suppose you want to find the reference angle for theta equals 5 pi over 6. Now you might not be familiar with how big 5 pi over 6 is. So if you want, you can convert it to degrees, or you can just rewrite as follows and then draw it. So I'm going to split up 5 pi as 3 pi over 6 plus 2 pi over 6. So the reason I use 3 pi and 2 pi because 3 and 2 are the factors of 6, and you can simplify them. So then I can simplify these. So 3 and 6 will cancel out. That will give me 2 on the bottom, so that's pi over 2, plus, and then 2 and 6 will cancel out. That would give me pi over 3. And these are the measure that you should be familiar with. Pi over 2 is 90, and pi over 3 is 60. So we're going to draw 90 plus 60. So now let's draw it. So we know 90 is right up here, and 60 just a little bit more. So that's the angle we have. This is 5 pi over 6. Now we need to find the reference angle for this. So we know the reference angle on the second quadrant is this piece right here. So we have this as our reference angle. So we know the rule to find this angle, it's going to be pi take away theta. Well, theta is 5 pi over 6. So we do pi minus 5 pi over 6. And then by using common denominators, we multiply pi with 6 over 6. So we have our reference angle is pi over 6. So that is the reference angle in radians for 5 pi over 6. Now let's do one last example. So now let's find the reference angle for theta equals negative 135 degree. Well, negative means you're going clockwise. So here's our XY plane. And so again, this is 0, this is negative 90, this is negative 180, negative 270, and negative 360. So we're going clockwise now. So negative 135 is somewhere between 180 and 90 negative. So this would be the negative angle. This is negative 135 degree. Now, because it's a negative angle, we know that we can actually find its coterminal angle, which we talked about earlier, and then look for the reference angle. Or you can just think of mentally that this piece is the reference angle. Now you can kind of say that, oh, well, it's bottom half of the circle. So if I just do 180 minus 135, I get the piece. But what if you want to show all the work and get to that angle? So what we can do is, so here's method 1. Method 1 is not so legit, but you can kind of do it mentally in your head. So think of it as all of these are positive values, okay? So do 180 minus 135, and you get the reference angle, because that's how much piece we're missing to complete the bottom half of the circle. So if I do 180 minus 135, I get 45 degree. That's my reference angle. But now what if you want to do it using the idea of coterminal angles? Since the angle is negative, you want to use the idea of coterminal. So what is an angle that is coterminal with negative 135? Well, Well, what we're going to do is we take 135 negative plus 360. So that would give me 225 degree. So that's the coterminal angle. So if I draw 225 degree, that will start from standard position and it will end up right here. That is 225 degree. So that's coterminal with negative 135 because they share same terminal side. Now from 235, we're going to find its reference angle. So as we can see, we already know what the reference angle should be, but we're going to check. So this is the reference. And let's check if it is 45. So in quadrant 3, we know the reference angle, it's going to be theta, which is 225 minus 180. That will be our reference angle. So if I do 225 minus 180, definitely this is 45 degree. So there you have it. You can do it any of these way, but I would strongly encourage you to do method number 2 because you get to practice the idea of coterminal and then relate that to reference angle. Okay, so I hope this makes sense.